So I don't think I introduced myself. I'm Paul Lavery from Edith, Cowan University in Western Australia. I'm going to talk today about the potential of seagrasses to contribute to blue carbon climate change mitigation strategies in Australia. So the evolution of this work, its genesis was back in a paper that myself and some co-authors published in 2013. And I'm prepared to admit now that that was a brutally simplistic study that we did, where we ran around Australia to try to get an idea of how much blue carbon there was in seagrass by taking some very shallow cores from 11 meadows. We only took 3 cores, and from that we did some massive extrapolation, and somehow or other we got away with it. And what it showed was that there was an enormous variability in the amount of carbon stored in these seagrass meadows, and we did some fancy, well, actually rather very simple multiplications and came up with an estimate that there was about 150 million tonnes of carbon in seagrass sediments, and that at the time Australia did have a carbon tax system, and if you could have put all that carbon into that system, it would have had a value of about $5 billion. And that grabbed lots of media attention. Everybody loved it. And there was a lot of talk about seagrasses could really get into carbon crediting mechanisms. In the same paper, we very carefully acknowledged that this was a very crude effort. There was a whole bunch of assumptions in there, and that if we actually did seriously want to put seagrasses into crediting systems, we were going to have much better information for this to have credibility for people to invest in it. And very fortunately, shortly after that, the CSIRO in Australia funded a major research initiative called the very sexy name of the CSIRO Coastal Carbon Cluster, and that had all sorts of people from all over the country involved in it. And the purpose of that was to dramatically improve these estimates. It was led by Peter Ralph and Carlos Duarte. It's had several programs in it. And one of the programs which I was involved in was to try to improve the estimates of the blue carbon stocks in the country: mangrove, tidal marsh, and seagrass. So what I'm going to do now is show you some of the initial outcomes of that in a paper which we've drafted up. I'm going to start including tidal marsh and mangroves and comparing those against seagrass, and then I'll focus in on the seagrass a little bit more. So the part of the program that I was involved in had 2 objectives. The first was initially to improve the estimate of the aerial extent of these different blue carbon habitats in Australia, and that was done by updating the available literature and mapping, and remapping those habitats and coming up with estimates of the area. The second part was to undertake a comprehensive sampling program of the 3 blue carbon habitats around the country, collecting about 1,000 cores and supplementing that with literature to get an idea about what the variability of carbon stocks was around the country. So what we did, we ran around, we got PVC pipe, we banged it in all over the place, got lots of cores from a whole bunch of different habitats. The cores varied from about 40 centimetres to 2 metres in depth. We treated them all pretty much the same. We sliced them at appropriate resolution, analysed each slice for its elemental organic carbon in there. We also, on a fairly significant subset, about 400 of the cores, we did lead-210 and radiocarbon dating, so that from that we could produce estimates of the carbon stocks, which we normalised all of them to 1 metre, and we could also produce sediment and carbon accumulation rates. I don't have time to talk about the accumulation rates today, so I'm just going to dump that. We ended up sampling over 1,500 sites around the country, and we got soil stocks for about 1,100 cores out of those sites. About 640 of them were seagrass meadows, and they covered monospecific and multispecific meadows in a range of different depositional environments, estuarine, exposed, sub and supertidal, and we had them in 5 different bioregions from arid to the temperate zones. All that data from all of that is now available, and if you want to use it, you can go in there and get it and do whatever you want with it. So we produced these new maps. Stuart Finn and Rob Cantor did a great job and produced new maps of estimating the extent of blue carbon habitats, and this is what they came up with. there's not much mangrove and tidal marsh compared to seagrass, between 10 and 20,000 square kilometres of tidal marsh and mangrove, whereas seagrasses dramatically increased the estimate to about 125,000 square kilometres. So aerially, seagrass is the big one. But when you actually look at the amount of carbon in a square metre of seagrass, it's a bit the opposite way around. So here we have the stocks of carbon, kilograms of carbon per metre, organic carbon per metre squared, in the 3 different habitats. And what we see is that mangrove has a lot more than seagrass. Tidal marsh has got a bit more. Mangroves, that's largely because mangroves have got a very large stock in their living biomass. Seagrasses have got very little. Averaged across all the Australian systems, 98% of the blue carbon in seagrass systems is in the sediments. However, when you put that together with the graph I just showed you about the aerial extent, you can then come up with estimates of the continental stocks, and it looks something like this. So seagrasses, in terms of millions of tonnes of organic carbon, we're talking about something over 1,000 million tonnes or 1 billion tonnes of carbon, driven not so much because of the density of carbon in seagrass, but by its massive extent compared to those other habitats. That carbon, that 1 billion tonnes, is not distributed evenly around the country. If we classify the meadows according to the bioregional classifications that we have for the country, what we see is that the tropical meadows have by far much lower stocks than most of the other areas in the country. So that's this stuff in blue up here, and we think that's largely because we're talking about small colonizing species. They're turning over rapidly. There's lots of cyclones and other things that's preventing carbon accumulation, and so we don't get much carbon being accumulated there. In comparison, these arid and semi-arid areas, and particularly Shark Bay and Spencer Gulf, these areas are dominated by the very large, persistent meadows with large amounts of below-ground biomass, and they're pumping a lot of carbon into those sediments. And so we see very significant stocks in these places. In fact, Shark Bay, Ariane has just led a paper reporting on the stocks in Shark Bay, and is estimating that there's about 1.5% of the global seagrass blue carbon is just in that one area here. And if you read her latest paper, you'll know that 36% of that meadow got wiped out in one heatwave event a few years ago, putting all of that carbon at risk. So, when you add all that up and you look at all the different meadows that you've got around the state, around the country, the green stuff here is the seagrass. You can add all that up, and as I said, we've got about 1 billion tonnes of organic carbon in the system, which equates, on current estimates, to about 15% of the global seagrass blue carbon stock, accepting, as we saw yesterday, that there's a whole bit of Southeast Asia that we don't have a lot of information for. That new number, therefore, is about 7 times that initial 2013 estimate that I put up. So I think, Ariane, you suggested we should reduce the accretion rate 7-fold. So I'm countering that. I'm saying we should increase the stocks 7-fold, okay? Now, the important thing is that all of this carbon is potentially at risk of being remineralized should we disturb those seagrass ecosystems. Now, of course, we're not going to disturb all of the seagrass meadows around Australia in one hit. But if we have a look at the current situation, if we use Michelle Waycott's paper on seagrass decline, for Australia, Michelle's paper suggested there was somewhere between 1% and 3% per year of the meadows were being degraded. So if we take the midpoint of that and say 2% per year is being affected. So we've got an area of about 125,000 square kilometres with 1,000 megatons of carbon in it. And if we're losing 2% a year, then that's 2,500 square kilometres a year that is at risk. If you then take the ICPP suggestions on remineralisation rates following disturbance, because we don't actually have emission rates for most of these systems, you can come up with a range that if all of that habitat was disturbed, you could potentially be releasing somewhere between 5 and 16 megatons of carbon per year into the atmosphere. So that's an annual contribution. So what does that equate to? Well, If you take the 2014 National Greenhouse Gas Inventory for Australia, that equates to about 16% of all the fossil fuel CO2 emissions in Australia. So it's quite a significant proportion of the national emissions that are going on. To put that into a different context, I've done some pictures. It equates to the carbon released in a year from about 1.5 million houses of Australians, who are the most CO2 intensive people on the planet. 3 to 4 coal-fired power stations, or the emissions from about 3 million cars driven for a year. So this is potentially what we're putting into the atmosphere at current rates of disturbance, suggesting that there's great motivation for conserving seagrasses. In order to benefit from that carbon in crediting schemes, however, you have to be able to put it into a crediting scheme. So the potential is significant. But the reality is that in Australia, the main way for getting carbon credits is through something called the Emission Reduction Fund. And the way that works very quickly is that a proponent comes up with a scheme like, I will restore a seagrass meadow, or I will conserve a seagrass meadow, and they go to the government and say, this is my project. The government will assess the project, and if the project meets with the requirements of an approved method, they will give the proponent some carbon credits which they can sell either in the voluntary market or back to the government. The problem for seagrass is that there is no method. In fact, there's no method for blue carbon in Australia at the moment. We have been advising the government, we've been showing them the results of this. The Department of Environment and Energy is keen on embedding it, but at this point it's still theoretical, they're still considering the information we've given them, and there actually isn't a method in place. So despite that potential, it can't actually be realised. So, in conclusion, I think this new study has modified our early estimates. It shows that Australia's got very significant seagrass blue carbon resources. We know those resources continue to be at risk, and the problem with that is that given that there's about 15% of the global seagrass blue carbon there, that's not just a risk to Australia, that's actually a risk to the global carbon cycle, given the extent of carbon that's trapped in those systems. We've got great potential to conserve or enhance our existing seagrass meadows if we can get them into blue carbon crediting schemes. But methods need to be developed to do that, and they're not there at the moment, although they are being considered. The final thing I'd like to finish on that's come out of this study, I think, is that we've learned a lot of things, but there's two very interesting ones that we've learned. The first is that we've put more and more and more effort into improving our estimates of carbon stocks and carbon accumulation rates. And we do all sorts of things to reduce the error in those estimates and get it very precise. And then somebody like the guys up in Queensland come along and suddenly produce a paper that says, oh, actually, there's 35,000 more square kilometres of seagrass than we thought before. Our mapping is atrocious, and particularly for seagrass. We don't know how much is out there. So the error terms in the extent side of the equation are massive while we're fiddling around resolving the error terms on the stocks. So might not be the sexiest research in the world, but we have drastically got to improve these estimates here. And the second is that we may well know the stocks, but we don't know what the emissions are when we disturb those stocks. And we really do need a lot more empirical work to understand when we disrupt a seagrass meadow, will 0, 25, 50, 75, 100% of that CO2 be remineralized, and over what time period? So that's another area that I think we really need to work on. And I will finish there. Thank you. Do we have time for questions? Or yeah? Any questions? Yeah. I don't know whether I cut it out last night. I don't know whether I've left it at the back. Yeah, here we go. So we did a two-layered assessment for the government on exactly that question. They asked us if you were trying to put blue carbon habitats into something like the ERF or a RED plus sort of mechanism, what are the sorts of projects that would be potentially viable? And the first part was what they called an abatement integrity assessment. It had to pass certain minimum requirements. If it passed those with a high enough score, we then went on to a second assessment to see how much carbon would you potentially get and how much abatement would you get. We ran a workshop with stakeholders invited from all over the country. They had input on what would be appropriate methods. And basically, through that assessment and that workshop, these were the sorts of seagrass projects which came up as priorities for consideration of a method. So the main ones are avoid losing them in the same place. So avoid dredging and avoid eutrophication so that you can keep your stock in place. And then the others were re-establishment of seagrass meadow that has been degraded. And we heard in the session this morning on restoration that there's some promising stuff there. Or creation of new seagrass meadow. They were the two that were considered most viable. And then the fifth was what we just heard a minute ago, was actually not doing anything with the meadow, but treating the rack that is emitted from the meadow, using that as biochar to prevent that carbon being remineralized and going back into the atmosphere, given that it's such a large proportion of the production. Yusra?
We just did this for North America, for the Gulf of Mexico, which is in press, should be out next week. And the mangroves were 366 teragrams in the Gulf of Mexico with an extent of 650,000 hectares, and the seagrass were 184 teragrams with an extent of 1 million hectares, and the marsh is 109. Now, on the east coast, from Florida up to Newfoundland for North America, it was 225 teragrams, with the marsh being most of it and the seagrass only 500,000 hectares. So altogether, 750. So the seagrass is dwarfed.
Yeah, I think it'll vary dramatically depending on where you are in the world. I mean, you saw, I didn't point out the error bars on those seagrass stocks, but the error bars are enormous. I mean, the variability is massive. And depending on where you are and what type of meadow you've got, and depending on the extent of the habitat. So if you look on the east coast of Australia, the extent of Posidonia is way, way less because it only occurs in the estuarine regions over there. In Western Australia and South Australia, you've got these massive areas of open ocean that can support the same big species, and therefore you get massive stocks. So, you know, it's going to vary everywhere. I think there's no doubt that from an NGO and the government perspective, there's a lot of pressure to look at mangroves rather than seagrass, because mangroves have got a lot of carbon in them. Their extent isn't as great, but they've got a lot of carbon in them, and it's a lot easier and more straightforward to rehabilitate or create mangrove habitat than it is seagrass habitat. So, you know, different parts of the world, different approaches may end up playing out.
Right.
Okay, I think we better finish it.